Oxidation is a reaction that alcohol undergoes, and alcohols they change into carbonyls. In this type of reaction, I am simply losing hydrogens. By definition, oxidation is either losing hydrogens or gaining oxygens. In this reaction, to be able to lose a hydrogen, I need to look for the carbon that is connected to the OH. So this is going to be my OH over here. The carbon that is connected to the alcohol first has to have a hydrogen. If it doesn't have a hydrogen, let's say if it's a tertiary alcohol, then the reaction will not happen. No oxidation will happen. But if it has a hydrogen, so we're talking about the case of primary and secondary alcohols, then the carbon is going to lose a hydrogen and the oxygen of the OH will lose a hydrogen as well. So see here, you are breaking two sigma bonds. You're breaking a sigma bond here and you're breaking a sigma bond in there. And by definition, when you break two sigma bonds, you are going to form a pi bond. There are different oxidizing agents that we're going to use for this reaction, and these oxidizing agents, they are going to vary in strength. And based on how strong the oxidizing agent, that is going to determine what type of carbonyl we are going to get. There are three types of carbonyls that we are going to form in this type of reaction. We can form either an aldehyde, and the aldehyde has a molecular formula or a general formula of RC double bond OH. By now you need to know your functional groups. We can form also a ketone, and we can form a carboxylic acid. A ketone has a general formula of an RC double bond O and an R, and the carboxylic acid has an RC double bond O and an OH. So you can see over here that what's varying is a group that is connected to the carbonyl over here. So we are going to get three different types of products depending on how strong our oxidizing agent is and depending on what alcohol we start with. So by definition, if we start with a primary alcohol and we use a strong oxidizing agent, then in this case, we're going to form the carboxylic acid. If we start with a primary alcohol and we use a mild oxidizing agent, which is not very strong, then we're going to go ahead and form an aldehyde. So aldehyde and carboxylic acids are formed whenever we start with only primary alcohols. On the other hand, if we start with a secondary alcohol and use any type of oxidizing agent, mild or strong, then we're going to end up getting the ketone. So let's look into the different types of oxidizing agents. There are strong and there are mild. The strong ones are water soluble, so you can easily know that they are strong because you look at those and in their solvents you see water in there. So if you see sulfuric acid is basically water based. So you know that sodium dichromate is a strong oxidizing agent. Any metal, chromium, manganese, these are strong oxidizing agents. So any one of those together with the Jones reagent. So Jones reagent is simply a combination of chromic acid and water. This is sodium dichromate. This is a chromic acid. All of these, they function the same. And all of these, they are good with primary alcohols and with secondary alcohols as well. But precisely with primary alcohols, whenever you use them, you're going to immediately get the carboxylic acid because they are so strong oxidizing agents that you're going to form the carboxylic acid right away. Whenever you're doing the oxidation, if you start with a primary alcohol and if you use a mild oxidizing agent, you're going to pass by the aldehyde. And then if you use another oxidizing agent, so if you oxidize further, you're going to go ahead and get the carboxylic acid. So you can see that the carboxylic acid is the last oxidation of the alcohol. and you approach the carboxylic acid, or you form the carboxylic acid, if you use a very strong oxidizing agent, then you go from the primary alcohol immediately to the carboxylic acid. The intermediate is the aldehyde between the acid and the primary alcohol. So if you're using a mild oxidizing agent, then you're going to get the aldehyde. You're not going to get the carboxylic acid. So with mild oxidizing agents, these are water insoluble. So we call those organic acids in there, or organic oxidizing agents. They are organic solubles, and they are organic soluble. And those type of oxidizing agents, we're just going to consider just one of them, which is the pyridinium chlorochromate, PCC. PCC is not water soluble, so you immediately know this is a mild oxidizing agent, and that mild oxidizing agent will not continue the oxidation of primary alcohol all the way to the carboxylic acid. It will stop at the aldehyde. So primary alcohols with mild oxidizing agent will get you an aldehyde. Now with secondary alcohol, it really doesn't matter the type of oxidizing agent that you use, whether you're using mild or you are using strong ones. You're simply going to get a ketone. What matters is the primary alcohol. With a strong, you get the carboxylic acid. With mild, you are going to get the aldehyde. Tertiary alcohols have no reaction whatsoever, because tertiary alcohols, they do not have any hydrogen on the carbon. So this is why there will be no reaction with tertiary alcohols. This is an example over here. Just look at the carbon. The carbon has no hydrogens. So this is why you cannot undergo any oxidation on this carbon here. By definition, to have oxidation, the carbon that is connected to the OH needs to have a hydrogen, and the oxygen also has a hydrogen. You are breaking two sigma bonds to form a pi bond over here. So if there is no sigma bond next to the carbon, there will be no reaction. Let's have an example in here. So primary alcohols, this is a mild oxidizing agent. We are not adding carbons in these reactions. So you need to locate your carbon that has the OH. Go ahead and locate that. And then check what type of carbon is this. This is a primary carbon. I'm using a mild oxidizing agent, so I know that my product is going to be an aldehyde and not a carboxylic acid. So all what you need to do is lose two hydrogens in there. And the hydrogens that you are going to lose here, I have two hydrogens. So you're going to lose a hydrogen here and the hydrogen there, and simply make your carbonyl. So you're going to end up having a carbonyl and the hydrogen, and this is going to be the aldehyde. Notice that I have the same number of carbons here, same number of carbons there. I'm not changing anything. This is a strong oxidizing agent now because it's a water base. This is a chromic acid. It's a Jones reagent. So it's a primary alcohol. So I am going to form a carboxylic acid. So the aldehyde is going to be the intermediate, but I'm not going to form the aldehyde. I'm going to oxidize it further. So in this case, you are going to end up taking the two hydrogens in there and the hydrogen over here, and you are going to introduce an OH also. So that is going to be your carboxylic acid. Secondary alcohols with a strong oxidizing agent are going to form a ketone in this case. It's a straightforward reaction where you are losing a hydrogen from this carbon and the hydrogen from this oxygen, and you are forming a double bond. This is a secondary alcohol, strong oxidizing. All secondary alcohols, whether it's a strong or mild oxidizing agent, you're going to end up getting your ketone. And then this is a secondary alcohol with PCC. Again, you're going to end up getting your ketone. Tertiary alcohols will have no reaction whatsoever because there is no hydrogen on this carbon. There is a hydrogen here, but there is no hydrogen on the tertiary carbon, so there will be no reaction.